My name is Mr. Scott, and I'm going to be helping you with sketching sine functions. Let's begin by becoming familiar with a few properties of sine functions. Suppose y equals a times sine of b times theta, with a not equal to 0, b greater than 0, and theta in radians. One property is that the absolute value of a is the amplitude of the function. Another property is that b is the number of cycles in the interval from 0 to 2 pi. And the final property is 2 pi divided by b is the period of the function. Now, we can sketch a sine curve by using 5 points equally spaced through one cycle. And there are two situations we want to be able to handle. For a greater than 0, this 5-point pattern is 0 max, 0 min, 0. And for a less than 0, this pattern is 0 min, 0 max, 0. So let's use this information to work through an example problem together. In part A of this example, we want to sketch one cycle of a sine curve with amplitude 4 and period 4 pi. So to set up our graph, let's write the scales for our theta axis and the y-axis. Since our amplitude is 4, we need to be able to cover that amplitude, and we'll make our scale on the y-axis. We'll go by 2's up to 6 and down to -6. So that'll cover our amplitude of 4. Our period is 4 pi, so let's come out here and label that 4 pi. And now let's divide this 4 pi into 1/4. 1/4 of 4 pi is pi. 1/2 of 4 pi is 2 pi. 3/4 of 4 pi is 3 pi. So now that we've got our axes labeled, let's go ahead and work on the graph. Our value of a here is greater than 0. So our 5-point pattern is 0 max, 0 min, 0. So our first point we're going to graph is 0. Next we want the max. Since the amplitude is 4, the max is 4, and that's located at pi. Next we want to graph 0 at 2 pi, followed by the min. The min will be -4, located at 3 pi. And the final point in our pattern is 0, located at 4 pi. So now we've got our 5 points in the 5-point pattern, and all we have to do is connect them with a smooth curve to get our graph. Okay, so here's our graph through one cycle with amplitude 4 and period 4 pi. Now let's move on and try part B. Here we want to use the form y equals a times sine of b times theta. We want to write an equation with a greater than 0 for the sine curve in part A. Recall from our properties of sine functions that the absolute value of a is the amplitude, and 2 pi divided by b is the period. So there are a couple statements I want to be able to fill in here with some information. First, the amplitude is 4, that's given to us in part A, and a is greater than 0. So that means our value of a is 4. Now let's talk about what the period tells us. Since the period given to us is 4 pi, and 4 pi equals 2 pi divided by b, I want you to take some time right now to find the value of b for our equation. When you think you have the correct value of b, hit the continue button to move on. Okay, welcome back. Hopefully you got 1/2 for the value of b. And here's how you get that value. Remember that 4 pi equals 2 pi divided by b. So we can multiply by b on each side of this equation. That'll give us 4 pi times b equals 2 pi, because the b's cancel on the right side. Now we want to divide by 4 pi on each side of the equation to isolate b. And we get b equals 2 pi divided by 4 pi, which reduces to 1/2. So now we have the value of b and the value of a, and we're ready to write our sine function. Remember, we want to write it in the form y equals a times sine of b times theta. So we'll have y equals 4 times sine of 1/2 theta. And there you go. We're all set with part B of this example. Now remember the steps that we followed. We sketched our graph of one cycle of the sine curve using the amplitude and the period, and we set up our axes with scales depending on that amplitude and period. And we wrote our equation using the amplitude and the period and the properties of a sine function that we covered in the beginning of this tutorial. I hope you found this explanation to be helpful. And when sketching sine functions, work well.